Welcome to our lecture Fundamental of Casting and Solidification. We are going to discuss our lecture 10, which is going to discussion on aspiration effect. Before going to aspiration effect, we have left one small section, that is horizontal and parting line gating system. In previous lectures, we have discussed top gating system and bottom gating systems. In what is happening with parting line gating system, what happen if casting in both cope and drag mold and your parting line, your gating system at the parting plane. In that situation, we have to feel it take advantage of both. First, just assume you are ignored from the top part. First ignore top part, cope part. So, it's look like as a top vertical gating system. So, you can feel fast in bottom section. Okay. Now, after the filling of this, just ignore this part. So, you will start filling stack by stack. It will be bottom gating system. It will behave as a bottom gating system. So, it is a summation of both top and as well as bottom gating system. So, what is someone want to know the filling time, so you have to divide your mold in two sections. For first half will be first section, first half will not necessarily on the 50% only. First bottom part, drag part will be calculated at a TF will be TF top volume of casting divided by AG into 2G HT, and half or remaining part bottom AM by AG root 2 by G HT minus HT minus HM, and you have to add both, then you can calculate your filling time for the parting line gating system, and this give advantage of both bottom and top gating system. So, what happens in last questions, we have seen 21 second for the 21 second and 43.71 second. Okay. So, what will happen here if same casting we are going to use? So, time will be in between. In bottom parting line case, the filling time will be in between both. Okay. Maxima will be happen when bottom gating, minima will be top gating. So, parting line gating or horizontal gating will give the filling time will be median of both. Okay. Not mean or medium. Okay. I am just want to say in between this value, in this range. Okay. So, it give advantage, there will no turbulence because velocity is less. So, it will give benefit for the bottom gating system, as well as time of filling will be faster compared to the bottom gating. So, you will fill the mold easily. So, both it will give benefit. Now, air aspirations. Okay. For a mold made of permeable material, case should be taken to ensure that the pressure anywhere in liquid stream does not fall below the spheric pressure. Okay. For a mold made of permeable material like sand, permeable material like example sand casting case should be taken to ensure that pressure in liquid metal should not fall below the atmospheric pressure. We have to ensure that. Otherwise, if let us assume it is not happen, what will happen? Otherwise, gases originating from baking of organic compounds or evaporation of moisture in mold will enter the molten metal stream, producing or affected. Let's assume if your pressure is not atmospheric, lower than that, let us assume you are not able to maintain, then what will happen? The gases originating from the baking of the organic compound like binders are there, clay is there, resins are there, and some moisture is also there, green sand casting, there is some moisture, let us assume some moisture is there. What will happen? They will evaporate, the baking of organic will, the gas will generate. If permeability is sufficient, it will go out. Otherwise, what will happen? If pressure is less in the liquid molten metals case, okay, sprue and all, what will happen? The liquid will not, gases will not go out, that will interact with the molten metal and that will mix with the molten metal and create porous casting, obviously blowhole, pinhole, gas holes, okay, blowholes, such defect or defecting casting we will get, okay. This is known as air aspiration effect, okay. This is known as air aspiration effect. What is happening? If your pressure is more than atmospheric pressure, obviously gases is going to generate, that is reality. It is not like that if pressure is less only then will generate, pressure then only gas is going to generate. Gases and moisture is going to, moisture evaporation is going to happen in any situation. But if your pressure is less, the gases will come to the molten metal. If pressure is more than atmospheric pressure, they will go out of the mold, okay, and outside there will permeability will play the role. If less pressure in the molten metal, the gases will attract to the molten metal, simple. If molten metal attracts that gas and it will produce a porous and defective casting, this is known as the gas or air aspiration effect. I will go through a basic example. Take, we will go for tap, or we will open the tap, you will see the at the tap inlet, the diameter of the water jet is something, some diameter, let us assume 12 mm. As your jet is going down, you will see the jet diameter continuously decreasing, okay, jet diameter continuously decreasing. This why it's happened? Due to gravitational acceleration, velocity increases as the stream falls, okay, root 2 g h. Okay, at top getting also we have said, seen velocity is proportional to the h. As height is increasing, your velocity is increasing. So, what happened? Rho a1 v1 equal to a2 v2. Here area is high, area is low. Obviously, a1 v1 equal to a low v high, isn't it? If top has area high, so velocity is low, as bottom has higher velocity because of gravity, so area should low, isn't it? That is mass continuity equation you have to observe. Okay. So due to gravitational acceleration, velocity increases as the stream falls, so that the cross section area of the stream must decrease proportionally to maintain the flow rate balance. To maintain the flow rate, the cross section area should decrease. This result a tapered shape vertical free fall system. Okay. This indicate a typically a tapered shape. You can see here nature of the free fall water is tapered, not straight. Okay. It is not looking like, isn't it? And the reason we have understand, due to the gravitational acceleration, if velocity is increasing, so area should decrease along the height. Okay. So, it is basic understanding we get from the our simple visualization of nature. Okay. If the same flow is directed down a straight side sprue like this, a straight side sprue, the falling stream will create a low pressure area. Here what will happen? The vacant place, low pressure area, it will pull away the sprue walls and will probably as air aspiration will occur. If low pressure area, what will happen? It will attract gases from the baking of the mold or evaporating moistures, gases will attract here and that will react here and it will form a oxide formation or some porous casting. Okay, that is kind of defect. So, what happened if this is the nature? So, if a straight sprue, that will be problem. So, to best will be make like this. We will understand why we need a taper sprue. Okay, is really taper is ideal condition and what will be the position. Okay. The tapered sprue is designed to conform the flow stream natural form, reducing the turbulence and possibility of air aspiration. Many type of high production molding units do not readily accommodate tapered sprue. So, the gating system design will try to approximate the effect of tapered sprue by placing a chokes near the base of the sprue to force the falling system to back into the sprue. We will understand this. Okay. In later section, what will happen if you are just want to use a straight sprue? First, why should not use a straight sprue? We will understand that. Then we will go what ideal design should. Okay. Then we will understand. Let us assume we want to use a straight sprue. So, what will be the possibility to remove air aspiration in the casting? That we will understand in third case. So, we have understand what is air aspiration. We will now understand mathematically. Let us assume top vertical gating system, top vertical gating system. Okay. This is point 1, point 2, point 3, this is mold, HM, HS, sprue height, basin height and that is total HT. So, we can write our Bernoulli equations. Equation between 2 and 3. Okay, we can write Bernoulli equation 0.2 and 0.3. So, what happened? P2 by rho g plus V2 square by 2g plus Hs equal to P3 by rho g plus V3 square by 2g plus 0. Since we have taken assumed it. Okay, we have assumed a straight sprue. So, what does mean? A2 equal to A3 obviously. So, A2 V2 equal to A3 V3. So, V2 equal to V3. We can write, if we can write 1 and this is 2 and we assume that in top gating system we assume that filling happen at atmospheric pressure. So, P3 equal to P ATM. So P gauge is equal to 0. Okay, so 1 will P2 by plus V2 square by 2G plus HS P3 by rho G V3 square by 2G plus 0, because V2 and V3 are okay, cancel out P3 P ATM. Okay. So, what you are saying, P2 equal to minus 2G HS, isn't it? What does mean? It is negative pressure. If you are making a straight sprue, what does mean? This is, it has negative pressure. At point 2, if A2 equal to A3, to avoid negative pressure at 2 or to ensure positive pressure everywhere in a sprue or liquid column, a sprue should be tapered. Okay, a sprue should be tapered kind of thing. Okay. So, this will convert into this 2 and 3 with not a straight sprue. A2 is greater than A3. R we define A3 by equation between 2 and 3, so that P2 equal to P3 equal to P ATM, isn't it? We are assuming that at 2 and 3 had minimum pressure, minimum. Okay, minimum pressure should be a P atmospheric. Okay, so P2 by rho G V2 plus V2 square by 2G plus HS equal to V3 P3 by rho G V3 whole square by 2G plus 0. Okay, checking since A2 V2 equal to A3 V3, so we can write V2 equal to A3 by A2 into V3, that is R V3, V2 equal to R V3. We can write V2 square 2G plus HS equal to V3 whole square 2G and V2 equal to R V3. Okay. So, we can say V3 is greater than V2. Okay, that we can easily say. So, when incorporating R square V3 square 2G plus HS equal to V3 square 2G, HS equal to V square V3 square 2G 1 minus R square. Okay, that we can write 2G HS divided by V3 square equal to 1 minus R square. What is V3? V3, okay, Bernoulli equation between 1 and 3, 1, 2, 3, HB HS HT, okay, P1 by rho g V1 square by 2g plus HT equal to P3 rho g plus V3 whole square 2g plus 0, P1 and P3 power P ATM, V1 equal to 0 due to HB constant, okay. So, V3 equal to root under G H2, that we know, okay. Okay, A I am writing. So, 2G HS divided by 2G HT equal to 1 minus R square, HB HS HT, okay. 1 minus R square equal to HS by HT, R square equal to 1 minus HS by HT, HT minus HS divided by HT, isn't it? R square equal to HT minus HS equal to HB divided by HT, R equal to A3 by A2, so indirectly what we are saying, A is inversely proportional to root H, H is inversely proportional to A square, isn't it, area whole square. Let us assume area is circular, cross section area is circular, so A is proportional to D square. We can write that H is proportional to D to power 4, isn't it? H is proportional to D to power 4. So, what does mean? So, it is saying as your height is changing, your cross section area will be parabolic. D to power 4 is a parabolic form. So, let us assume basin. So, you can say, okay, cavity, okay. What does it mean? That parabolic profile, the sprue design be parabolic, okay. Sprue should be parabolic to maintain all places P equal to, if you want to maintain minimum pressure of atmosphere at all place equal liquid column, the sprue should be parabolic, okay, and lowest area should be bottom and maximum area should be at 2, okay. But what is the issue with this? You have a curvature now, it is not a straight line. So, what happens? This is called ideal sprue, ideal, this is known as a ideal. Actually, I am not able to draw a parabolic. So, this is known as ideal sprue. This is known as ideal sprue. But in manufacturing of pattern, where you have to do? You have to do manufacture of such pattern. It is very difficult profile because it is a parabolic. Okay. So, its best way, can we use a tapered profile, straight but tapered. Tapered but straight. Can we use? Ideally, a sprue profile should be a parabolic, okay, but to ensure all pressure is atmospheric. But in reality, what we have to do? We are going to use a tapered profile, tapered state profile, actual taper sprue, which is used in industry because easy to make. Okay, if you are going to make ideal, it is best one, but problem is there to manufacturing. Okay, so what we do? We make a straight tapered profile. Okay, now someone want to know what is then happening. Ideal, red one is ideal, all place has P equal to PATM. Actual sprue at 2 and 3. At 2 and 3 has P equal to PATM. Other location P is greater than P atmosphere. You can check here. What is happening here? You are indirectly increasing the area. What does it mean? You are decreasing your velocity. What you are doing? You are decreasing your velocity. Ideal has some velocity this, so actual has lower velocity. If lower velocity, pressure should be not less than atmospheric. If ideal has PATM, so what happened here? Velocity is lower, so pressure should be higher. So what actual sprue say at point 2 and 3 has P atmosphere, pressure is minimum atmospheric, but other locations pressure is more than atmospheric. That's good, isn't it? So ideal sprue making is very difficult. So what people make? A tapered sprue. Okay, let's assume now it's easy to make tapered. Now some places it's very difficult to make a tapered sprue also. So what can we do? There are two methods. Okay, use choke core. So in if you have to make a straight sprue, if you have to make a straight sprue, so what happen? We have to use choke core at the bottom or runner choke, so that you can avoid air aspiration effect. If you have to make a straight sprue only, then you have to make this additional choke areas to reduce air aspiration effect. Thank you.